My name is John Sabaton. I'm based out of Singapore, and I've been with Mandiant for 2 years. My specialties is Active Directory tiering, okay? ESAE, if you've ever heard of that, the Red Forest, that was me, okay? So that's a little bit about me, okay? I'm gonna hand over to Rupa. You can say a little bit about you.
Thank you, John. I'm Rupa. I'm based in Singapore. I'm part of the Security Transformation Services APJ team. My specialization is identity and access management. I joined Mandiant a year ago because I'm so passionate about working with customers and helping them solve various security challenges and working in the front line.
Okay, you're on the... All right, so these are our objectives for this afternoon. Want you to go away with a really good understanding of tiering and how it applies to multi-clouds. Okay, we're going to have a look at the analysis of risks for multi-cloud in a hybrid environment. So that's one of the objectives. We're also going to hopefully give you an understanding of how tiering protects the cloud against threat actors. Okay. And then finally, we want you to go away with how to secure the multi-cloud environment using a tiering architecture. So those are the objectives. But before that, we're going to plug our white paper. So if you do the next one for me. Okay. Okay. Just quickly do one more. Okay, they've not updated the slides. Sorry about that. Okay, back. We did have a nice white paper slide, but it's not come through. So let's go back to the main agenda.
Sorry, the button's not working. Is this what? Yeah,
Okay.
The back button's not working.
So can you take it back?
Yeah, take it to the...
There we go, right.
Yeah.
Reset, let's go. So I'm going to give you an introduction to tiering. Okay, I'll give you an understanding of why that's important. So we're going to look at what is tiering, then we're going to look at defining tiering in the cloud. Rupa's going to take you through an attack path that we have seen, okay, the sort of things that we've seen. So we're going to have a walkthrough of that attack path, and then we're going to tell you how tiering will help protect against that particular attack path. So that's one example. And then this is the core piece of the session is how do we apply tiering concepts to Azure, AWS, GCP. Okay, so that's what we're going to give you. Okay. Right. Rupa, to you.
So when we look at customer environments with multiple cloud platforms, some of the common challenges that we face are disjoint identity and access configurations. Because with multiple cloud platforms, there will be multiple identity platforms to deal with, and the integration between them always don't line up. And that results in users having more than required permissions across different clouds. And those accounts become the sweet spot as a threat actor target. And if those get compromised, it gives an attacker permission to move across different cloud environments. Some of the other common challenges that we see are lack of zero trust approach to networking. So there's non-critical resources deployed in the same network segment as critical resources, such as domain controllers being deployed with applications which have internet-facing capabilities. And that exposes the critical services to various network-based threats. And then different cloud platforms would have different security control planes. And it is often a challenge for vendors to line those up so that our clients can actually have a baseline security configuration applied uniformly across all the cloud platforms. So with these security challenges, we take the example of a typical cloud environment that we would often see in our customer environments.
So this is not an unusual architecture that we see with our customers. So those people, we've got Moonbeam Energy. Okay, Moonbeam Energy is our fictitious company. It's an energy company that generates energy from moonbeams. Okay. It's running an on-premise Active Directory environment, which is synced via the AD Connect, the Azure Connect service, into Entra. And then we've got a SAML integration into GCP. So this way that we can use all our identities across all of the clouds, okay? I think you can see some of the issues that we could come across here, and that's what we're going to take you through. Okay, so next slide, and what we're going to look at is how can we take all the things that Rupert described and provide that as a unified pattern of practice across Azure, GCP, AWS, any other cloud as well. So these things that we're going to take you through can be applied, and concepts can be applied across Tencent, Alibaba Cloud, okay, Ali Cloud, as well as the big three that we're going to take you through now. But first, I've got a level set and make sure you've got a good understanding of tiering. Who has not heard of tiering before? Not you, Derek. Okay. Okay. A couple of people. Okay, so let me take you through what we mean by tiering. So credential tiering is a way of separating privileged credentials. And we do that into 3 tiers. Tier 0 is your critical infrastructure, okay, your trusted services infrastructure. And so anything that controls that infrastructure we class as tier 0, okay. Tier 1 is your line of business applications and any privileges that are associated with those line of business applications. And then tier 2 is your user endpoints, okay, and end user applications. Now let me explain these arrows. What we want to make sure is that a tier 0 credential does not log on to or get anywhere near a tier 2 or a tier 1 application. We want to contain those credentials within that tier. And you will see, same thing for tier 1. We want to make sure that those credentials stay within that tier, okay? Same with tier 2, because this is where the threat actors come in. So we want to make sure that there are no tier 0 privileges available for a threat actor to leverage, move laterally, and then escalate. Okay, so that's what we're trying to do with tiering. Okay. Right. I've given you some examples already, but I wanted to put it in a table so you could take it away, okay, and revisit and come to that. So, tier 0, trusted services infrastructure. Your identity services, privilege access management services, admin identities, network configurations, specifically in clouds, okay. Any virtualization hosts for tier 0 services, okay, that's kind of an important one. That's where we see a lot of threat actors coming in. Tier 1, business layer. So this is resources that contain the crown jewels for most businesses, okay. And then finally, end users. Okay, so this is our laptops, desktops, end users, user identities, okay. Right. Anything else you want to add to that, Rupa?
Yes, and why do we treat tier 0 to be the most critical? Because if there's a breach in our IAM services, that would mean a breach in the entire environment. If a threat actor holds the certificates or the secrets that encrypt our IAM services, they hold the keys to the kingdom, which makes it the most critical services to protect. However, when there's a breach in tier 1, the compromise is restricted to that application or workload. So that means the threat actor is able to compromise any data associated with that application server only. It's still impact, but still it's the next tier. And tier 2, it's an end user credential. So if a threat actor gets hold of that, then that end user credential is compromised. However, what we try to avoid is crossover paths between these tiers. So if there's crossover paths with a user having access to 2 different tiers with the same credential, then that can lead to an attacker having the opportunity to steal that credential and elevate privileges. Now, how do we define tiers? Because in a complex environment with so many different cloud platforms and on-prem workloads, we will be taking an approach where we look at the type of action and the persona and what tier that maps to. So for instance, if as an administrator, I manage the federation services to federate different workloads or applications to my identity server, I am a tier 0 admin because I have the capability to make direct changes to the identity service. Likewise, if I have the capability as an admin to reset session tokens MFA methods for all users, I am a tier 0 admin. However, if I am an administrator of a Kubernetes service which hosts an internet-facing consumer application, because maybe I'm a customer who hosts a consumer application, so that makes me a tier 1 admin. So this is the way we would identify and segment the different tiers.
Okay, so hopefully that gives you a baseline of where we're coming from when we're talking about tiering. Now what we're going to do is we're going to do an attack path analysis where we're going to walk you through a threat actor gaining compromise of the environment that I showed you earlier. Okay, so let's have a look again at the environment. So remember, this is Moonbeam Energy. We've got domain controllers, AD on-prem. We've got Entra, Azure environment, and we've got a GCP root environment. Now we're going to go and look at the attack path.
Now notice one thing here. There's domain controllers hosted in an Azure subscription, which also host dev test resources. There's public IP addresses because these applications which are hosted in app services need a public IP address. So all of these different resources are hosted in the same container or subscription. And same goes for GCP. There's one project which hosts all of their applications. And there is a AD Connect sync, which is synchronizing all their Active Directory identities into Microsoft Entra so that users can reuse the same account and log into Entra federated services. And Entra is also having integration with GCP identity, which means users can effectively use their AD credentials synchronized with Entra and GCP to log into all applications. Now we'll look at why this may not be such a good idea. So this is the attack path. We have an example user. And by the way, this is a scenario which is very common. We see it with a lot of compromises that we witness day to day with cloud environments. So we have Alex. Alex has an Office 365 account, and Alex also has access to Azure to create, update, delete, and read resources. So that is a typical owner or a contributor role if we are looking at the Azure RBAC role names. So with this account, Alex accesses emails and clicks on a phishing link, which is what a threat actor has planted, and that leads to the threat actor stealing Alex's token. Now, let's keep in mind that token replay is not the same attack as a credential reuse, because credential would mean the threat actor has possibly gotten hold of the username and password of the user. Even if the user has a MFA, the token can still be replayed and used to access different applications that would accept that token. The threat actor in this case reuses that token to access the Azure tenant. Here, the threat actor finds there are domain controller VMs, and the threat actor is able to take a snapshot of the data disk of the domain controller VM, mount that in a separate threat actor controlled virtual machine, and steal the AD database, which is the ntds.dit file, which contains all the usernames and password hashes of all the users in the domain. From here, this leads to the domain compromise. So the threat actor is able to crack the different accounts offline and get a domain admin account. The threat actor also gets hold of credentials which are synced from on-prem into cloud and are global administrators in Entra, and is able to compromise Entra. And because the same credentials are used to log into GCP, the threat actor is able to use an account with GCP admin privileges and compromise GCP cloud as well. So this leads to a total domain compromise. Now, if we look at the threat actor attack path and try to analyze what were the gaps that Moonbeam Energy Organization overlooked, we see that there was lack of segregation of identities and endpoints. A user who has such high privileges over domain controllers or critical resources should not be using the same account to log into internet-facing productivity applications such as emails, SharePoint, etc. Additionally, there were critical and non-critical resources in the same resource boundary. Then there's definitely gaps in monitoring and detection. Why? Because when a threat actor is replaying the token and performing so many activities such as stealing the ntds.dit file, logging in from an unknown device, an unknown location as a global admin and taking over the domain, that should flag an alert to the SecOps team, which was definitely missing. So all of these were leveraged by the threat actor to gain access to the environment. Now, as we have seen this attack path, let's delve into what tiering within multi-cloud environment would look like.
Okay, you saw earlier on that I put up the tier model diagram. Okay, what we've done is we've taken the tier model diagram and we've added the cloud components that you've just seen in the attack path to help explain how tiering is going to work in a cloud environment. I know it looks complicated, but it isn't. Okay, so if we just move it, there we go. So to help us understand, what we've done is we've helped color code. So here are the tiers that we've got. Now, this is what we're going to be expecting for tier 0. We are going to be expecting that anything that is residing in the cloud that we class as tier 0 does not have internet access. Okay, so no internet access. So those services cannot be contacted. So that's the first thing. Now, line of business applications, some of them are going to need internet access, but we need to control how that works. So that's going to be all down to networking design and configuration. Again, I want you to notice that we still have the same rule sets. We do not want those top tier 0 privileged accounts flowing down. Okay? Similarly, we do not want the lower privileges escalating. Okay? So exactly the same thing down at tier 2 and tier 2 services, internet access, and also networking being configured. Okay, just let you get your photo. Okay, right. So what do we need to try and do to help us with securing these cloud environments for tiering? We need to make sure that we've got the zero trust access controls, verifiable attributes, multi-factor authentication. And that is what we're going to start taking you through. The other thing on the far right-hand side, we want you to be doing continuous monitoring, okay, automated governance if possible, okay, all those sorts of things. But right now, we're going to take you through what it's going to look like.
So in this session, we are taking example of the 3 topmost used public clouds, AWS, GCP, and Azure. But of course, this tier model can be applied uniformly using the same principles to other cloud environments as well. So if we look at AWS, we are taking advantage of the organization unit and the account structure breakdown to define the different tiers. So we have got a tier 0 OU, tier 1 OU, and tier 2 OU to have all the resources and the accounts relevant to those tiers. We also make sure that there are AWS config rules applied at the relevant OU levels so that those help enforce the security policies and configurations necessary to harden the workloads deployed within that tier. For instance, we want to block internet access to S3 buckets and EC2 engines. That is something we enforce at the tier 0 OU level using a AWS config rule policy. Similarly, in tier 1, we may want to enforce encryption of different resources and application servers, and that is something we can enforce through policies. Additionally, we will be defining the roles to access and manage the different tiers and workloads. One key thing to note about AWS is that roles here are separate from users. So users in AWS would assume roles and then log on into the accounts to perform various administrative tasks. That gives us the opportunity to define roles and policies relevant to manage each of the different tiers so that the users can assume those roles and perform the relevant tier responsibilities.
Okay, I'm just going to jump in here, Rupert, and say, those of you that are familiar with AWS or any of the cloud vendors, there's always, they have, right, let's do a landing zone. This is the required architecture for how our cloud operates. We're kind of changing that a little bit in the fact that we're trying to standardize for our customers a way of being able to use identity across clouds in a standardized way, okay? So that is why this would look different from a standard AWS landing zone. Now, Rupert's going to take you through the next one.
Yeah.
Okay, and you'll see the same premise.
And one more thing to add is that any highly privileged permission that we don't want to be inherited across to all the accounts will be blocked at the relevant tier OU using service control policy. So that is one of the other controls that we'll be using to make sure that things are bolted down and secured in the various tiers. Moving to the next cloud, within GCP, we are going to use the folder structure to define the different tier folders and place the relevant projects for the different tiers within those folders. We are going to make use of org policies, that is organization policies, to consistently apply security baseline controls into each of the tiers, similar to how we did in the AWS. We will be applying controls to block internet access, encrypt resources, etc., at the relevant folder level. One key difference between AWS and GCP, and actually AWS and a lot of other cloud vendors, is that permissions applied at the higher level of the resource hierarchy, that is at the GCP organization or at the folder level, will inherit downwards. So any user who holds the owner or an editor role at any of these folder levels will have that access inherited across to all the resources underneath. We want to make sure that that is cut down as much as possible. Users are given access at the relevant project levels, following principle of least privilege, and we can use deny policies at the relevant folder levels to cut down any unintended inheritance of permissions. Coming to Azure, we are taking advantage of the management group and subscription hierarchy to define the different tiers and place the resources within the right tiers. Permissions in Azure as well would trickle down and inherit from the top down, which means any user who's an owner at the tenant root level or at the root management group level here would have access with the same permissions to all the subscriptions underneath. We have actually seen a lot of client environments where post an incident, there were thousands of service accounts, service principals, user accounts having owner contributor rights at the subscriptions, which contains a lot of critical resources. And they had no idea why, because those permissions are usually given to ease management of administrators, and administrators can just use the highest of privileges, because that is easier always to have the highest privilege and manage different things. So that's one of the things that we need to restrict as well. And we will be applying Azure policy initiatives at the root and the child management group levels at the relevant tiers to make sure that the proper security controls are applied.
Okay. Yeah, Derek, yeah? Sorry? So Derek's question is all this material in the white paper? Yes, it's all in the white paper, and the link to the white paper should be at the end of the deck. Okay, so yeah, so I'll talk through that towards the end of the presentation. So yeah, yes.
Will you be talking about
Okay, so the question was, are we going to be talking about how to prevent owners from changing access to different tiers?
Yeah, for themselves.
For themselves, okay. I will let Rupa answer that one.
So yeah, we will be actually going through how we can apply all the tiering controls in the environment that we saw earlier as an example. And we will answer the question of what we do with the highly privileged credential to make sure there's no lateral movement.
Okay, so any more questions before we move on and get deep? Okay, so we've set the stage. We've shown you how tiering is going to work from a structure perspective. Now we're going to take you through how do we do it. Okay, so what we're going to do is we're going to take you through the different processes. So we're going to look at resource segregation, credential tiering. We're going to look at separate administrator and productivity credentials. We're going to look at how we cut down the inheritance of privileges, which I think should answer your question. Okay. We're going to look at dynamic access conditions. So that's MFA. One of my favorite things, which is privileged access workstations. So we're going to have a little chat about that. A chat about network segmentation, monitoring, detection, and governance at scale. And I will hand over to Rupa.
So let's look at the first control that was applied for moonbeam energy. Now, in this diagram, the resources look a lot more structured than what we saw earlier. So there is tiering applied to Azure to place the domain controllers that we saw earlier underneath the tier 0 platform management group and subscription. There's tier 1 landing zone, which is further divided into dev and production to place all the internet-facing production resources in a separate subscription than the dev. And just to keep in mind that the tiering underneath the tier 0 and tier 1 is dependent on what the client needs. A lot of clients may require one or more than one subscription, depending on how we can further segment dev, production, and so on. Similarly, in the on-prem, we have got tiering applied to make sure there are the different tiered OU structure, and the domain controllers and the different critical servers are protected with the tier 0 group policies and controls.
So that's both within the logical AD structure, but also most customers are running Active Directory on a virtualization platform on premise. Okay, so we also need to look at the infrastructure that's running underneath to make sure that is also tiered. Okay, so that's part of what we do in our Active Directory modernization program.
Similarly, GCP environment is also tiered, and in this case, there is a tier 1 project hosting all of the GCP resources. So this segregation was important because it helped us place the resources in the right containers, and that would help us define the policies, the role assignments, apply networking segmentation as well as we move on through this exercise. The second control is credential tiering. So with credential tiering, we are making sure that the administrator credentials, which has the highest privilege in any platform, stay within that platform. So a common practice that we have seen is that clients would usually synchronize all of their credentials from AD into Microsoft Entra, and that exposes the administrator credentials from AD in Microsoft Entra. And similarly, when creating any accounts having the highest privilege in Azure, they tend to be on-prem synced account, which is a mistake, because if that account gets compromised in on-prem, then the threat actor has the ability to reuse those credentials, log into Azure, and take down all of the resources because they have admin access. So we need to make sure that any admin credentials in any given platform stays within that identity perimeter. So we have cloud-only accounts holding admin privileges for Entra, which is global admin, privileged role admin, any subscription or management group owners for critical resources and services, they are cloud only, and similarly for GCP as well. Moving to the next control of separation of credentials. So any tier 0 or tier 1 privileged account should be separate from a productivity user account, which means that account should not be used to log into a workstation which has internet access and access to a wider range of SaaS applications. Privileged credentials should only be used to perform administrative tasks from hardened specialized workstations known as privileged access workstations.
Oh, no, it's not me yet.
Yeah, okay, yeah, we have another slide. So cutting down inheritance of privilege. So there's limited scope of cutting down permission inheritance when it comes to Azure. There is something called as deny assignments, which only works through deployment slots and bicep and ARM templates. So if we have management groups and subscriptions created through the portal, unfortunately, the permissions would inherit, in which case we go through an exercise to review all of the user accounts, any application identities having permissions at the root management group level or at the higher level of the resource hierarchy, and remove any accounts which are either inactive or don't need permissions at that level. In GCP, we do have something called as deny policy, so we use that to restrict inheritance if the inheritance to the resources underneath is undesired. So that is how we would explicitly deny permissions to flow downwards. Does that answer your question?
The questions are specifically inside of like on-premise as an example. So we're doing credential tiering as well.
Okay.
I didn't know the term for it, but it's wonderful. Thank you for that. Where we have the domain admin accounts, we've got regular admin accounts, and end-user accounts, and we have different controls that prevent an admin account from signing into
Okay.
account
Yeah.
specifically. But the domain admin account level could edit any of these permissions.
Yes. So I'm going to take this one. This is, I could sit here all afternoon and walk you through all of this, but you should be using user rights assignments and restricted groups, okay? What we do is we use restricted groups in a group policy to remove domain admins from the local administrators group on a tier 2 endpoint. That way they cannot log on, okay? Microsoft doesn't always like this. If you look at their support statement, it says not recommended, which for me means do it. Okay. So it's not recommended because in a support incident, what they'll want you to do is put domain admins back in again. Okay.
And so we're doing a function. We're using group policy.
Yeah. So that's the first step that you will need to do for tiering. The second step is, in your mind, domain admins must only ever log on to domain controllers. Okay, nothing else. Okay, that's what you need them to do. So if you've got those things happening, that's pretty good. Okay, that's pretty good. That's you're far ahead of the field for other people in Active Directory. Talk to me afterwards. That's what I do. Okay. Okay, great question. Thank you.
Moving to the next control, we have specific tier 0, tier 1, and tier 2 credentials now. So the privileged credentials only can use cloud privileged access workstation or cloud POS, which are specialized devices, which are going to be enrolled to a MDM solution, restricted to access the internet.
You've just taken my line.
Hardened with different configuration policies, ADMX templates, etc. And those will be the workstations the administrators for tier 0 and tier 1 would use to access the different services that they are supposed to manage. And every authentication would be secured with MFA, and that is a phishing-resistant MFA, which is FIDO2 keys, so that we are minimizing the attack surface area using this approach.
Okay, so privileged access workstations is a particular passion of mine, okay? When we say cloud POR, we do not mean a virtual machine which is running in the cloud. That is not what a cloud POR is. But that's what people think it is, okay? A cloud POR is a physical device which is managed by cloud policies, okay? That's what a cloud POR is. All administration should be done from a physical device. And I do not mean productivity device and a virtual machine sitting on that productivity device. It must be the other way around. And that is The admin workstation is the base, and productivity machine is the virtual machine. Why? The admin machine, if it's tier 0, okay, must not be controlled by a machine which is tier 2. So if you've got productivity machine as the base, and the virtual machine being tier 0, you've got tier 2 controlling tier 0. Okay? That is an absolute no-no. And the amount of customers that I speak to and have trying to explain this, they go, oh yeah, you're right, the base needs to be a higher privilege than the virtual machine. For me, I personally prefer separate devices. One for administration, one for you going to your favorite Dancing Cats website. Okay, so productivity, administration. It's also the easiest management way to do management, having separate devices. Okay, so your admin's going, I've got to carry 2 laptops. Suck it up. Okay, it's safer. Okay, right, back to you, Rupa.
Network segmentation, so as we saw earlier, the resources were placed within their specific tier containers, and the network was separated as well, with firewall policies restricting any inbound and outbound traffic. And then finally, we have got monitoring, detection, and governance applied. All the logs relevant for identity, endpoints, and any other critical servers are sent to a central CM solution, and there are detection rules created for proactive anomaly detection and threat analysis.
Okay, so this brings us to what happens to that attack that we outlined earlier once we've put tiering controls in place. Okay, so this is the diagram that explains if we had had tiering, how far would that account have got and how far would the compromise have got?
So now we have Alex, who has a productivity account, which is synchronized from on-prem into Entra. It is also synchronized into GCP because there's a SAML federation. So this account can log into any SaaS application and any productivity application. Then there is the tier 0 account, which is the cloud-only account, because this has Azure privileges, and Azure has domain controllers. So now when Alex logs into email, Alex uses the productivity account and gets phished. The threat actor steals the token, replaces the token, tries to log into Azure but is blocked, because as part of the tiering controls, we have blocked admin portal access, any API or command line access to any of the administrative planes for Azure. And there is no Azure privilege. So even though the threat actor was able to access, which they aren't, they wouldn't be able to see any resources. Now, the organization had also deployed monitoring and threat detection in place using a SecOps product, and that sends a trigger to their SecOps team, and they go ahead and proactively reset Alex's credentials and MFA methods and any session tokens which are active, thereby cutting off the threat actor's attempt to log into any services. So that stops the attacker in their tracks.
On the left-hand side, you'll see that we've given Alex a dedicated privileged access workstation which has tier 0 access. That is where the credentials for him to perform his admin work is used. So we've completely separated that environment. Okay, that's really what I want to see from you. Okay. All right. Next one, I really want you to have your cameras out for this one. Okay. It's the white paper. So what we've done is everything that you've seen this afternoon is explained in glorious detail in an 85-page white paper. Okay, where we go through Azure, AWS, and GCP, those detailed controls. Okay, this is version 1 of the white paper. We're expecting to add further elements to it. Okay, so it should hopefully stay at that particular location. Okay, so please download it, please read it. It's pretty neat, and congratulations, Rupa, on having that published. Yeah. That's great.
And you.
Okay. The very last slide before we'll open for questions is hopefully you've got a good idea of what tiering is all about and how we can apply it to multi-cloud. I hope you realize that it's actually fairly simple concepts, okay? But it has a dramatic impact on the way that your clouds can be managed and protected from threat actors. My name's John Sabaton. This is Rupa. Thank you. You may get your planes now. Okay, so thank you.